A shaft which rotates at a constant speed of 160 rpm is connected by belting to a parallel shaft 720 mm apart, which has to run at 60, 80, 100 rpm. The smallest pulley on the driving shaft is 40 mm in the radius, that is smallest pulley R1. Determine the remaining radii of the two step pulleys for first, that is a cross belt drive, and second an open belt drive, neglecting belt thickness and slip. So we are considering over here that is the belt thickness is 0 and there is no occurrence of slip. So first of all we will consider what is given. So finding the solution, that is we will write down what is the given in the problem statement. So in the problem statement what is given, that is speed of the driving shaft, and if we consider the driving shaft, this is a driving shaft which is having the 3-step pulley, first pulley, third pulley and the fifth pulley, while the driven shaft is again having the 3 pulleys, second, fourth and sixth, and the distance between the 2 pulleys 720 millimeter. So what is given, it is moving with a constant speed of 160 rpm, that is driving shaft is moving with a constant speed of 160 rpm. Therefore we can say n1 is equal to n3 is equal to n5 is equal to 160 rpm. This is given, right? Apart from that, what is given? X is given, the distance between the center of two pulley, and this X is 720 millimeter apart. Now N2 is given, that is which has to run a driven pulley, N2 is given, what should be the N2? 60 rpm, while N4 fourth pulley should run with the 80 rpm, and the N6 is 100 rpm. And then R1 is given, that is the radius of the smallest pulley on the driving shaft is 40 millimeter. So we have to find out the radius of all pulleys on the driven shaft, right? So let R2, R3, R4, R5 and R6 are radii of the pulleys two, 3, 4, 5 and 6 respectively. So first of all we will consider a cross belt drive. So first, for cross belt drive, we know velocity ratio for first and second pulley. Now we will consider the combination of first pulley and the second pulley, and the velocity ratio for the first and the second pulley, that is N2 divided by N1 is equal to R1 divided by R2. This tends to N2, we know the N2, this tends to R2 is unknown over here, so R2 is equal to R1 multiplied by N2 divided by N1. So R1 is known, that is 40 millimeter, N2 is just a minute, we have to correct this. Okay, this formula R2 is equal to, if we take out this, R1 multiplied by N1 divided by N2. This tends to R2 is equal to R1 is how much? 40. R1 is 40 millimeter multiplied by N1. N1 is given, that is a 160 rpm, divided by N2 is given, that is 60 rpm. And this turns out to be 106.7 millimeter. And for pulley 3 and 4, we can write down N4 divided by N3 is equal to R3 divided by R4, or we can say R4 is equal to R3 multiplied by N3 divided by N4. This tends to R4 is equal to, R3 is not known, but N3 is known, that is a 160, and N4 is given, that is 80, and this is equal to, this tends to R4 is equal to twice R3, right? But for cross belt drive, we know R1 plus R2 is equal to R3 plus R4 is equal to R5 plus R6, and this is equal to R1 and R2. We have find out, that is 40 plus 106.7 is equal to 146.7 millimeter. How this comes? So for this, actually we have already seen, that is, it may be noted that for expression of functions R1 plus R2 for the cross belt drive, the length of the belt is a function of R1 plus R2, that is summation of radius of the two pulleys. Thus, if the radii of the two pulleys are constant, then the length of the belt required will also remain constant, provided the distance between the center of the pulleys remains constant, and this is the case. This is the case for this particular problem, and that's why we are saying that is R1 plus R2 is equal to R2 plus R3 R4 is equal to R5 plus R6. That is the total length for this radius, summation of the radius for both the pulleys for the cross belt drive will be same, and by knowing this, we can write down over here, that is what expression, R4, if we consider the third and fourth pulley, that is R3 plus R4 equals to 146.7 this tends to R3. What is R4 now? So R4 we have found out R4 is equal to twice R3. So writing in this term, that is R3 plus twice R3 is equal to 146.7. This tends to R3 is equal to 146.3 divided by 3, and then the R3 comes out to be R3 is equal to 48.9 millimeter. So we got one answer, that is R3 is equal to 48.9 millimeter. So this is what we have found out R3. Similarly, we will consider the pulley, combination of pulley, that is R5 and R6. So for releasing the space, I will clear all this, and now we will consider for pulley 5 and 6. We know for N6 by N5 is equal to R5 by R6, or this tends to R6 is equal to R5 multiplied by N5 divided by N6. This tends to R5. N5 is known, that is 160, and N6 is known, that is 100, and this turns out to be 1.6 times R5. So we got what? R6 is equal to 1.6 times R5. So as we know, that is R5 plus R6 is equal to 146.7. So from this, what we can get, R5 plus 1.6 R5 is equal to 146.7, and from this what we get, R5 is equal to 146.7 divided by 2.6, and this is equal to 56.4 millimeter. So that is what we got solution, and thus we can say R6 is equal to 1.6 R5. This tends to 1.6 into 56.4 is equal to 90.2 millimeter. So in this way we find out the solution for this.